All right, you can all hear me. Hello, everyone. So I'm really glad to be here today. I'm going to be presenting our work, a framework and toolkit for testing the correctness of recommendation algorithms, as Ashmi already said, which I did in collaboration with Robin, Andres, Kim, and Bart. Since this is the last session on the last day of RecSys, and I and several others here have enjoyed a wonderful banquet and maybe a karaoke session after, I decided to tackle this a little bit differently, and I'm going to spend most of this talking to you about apple pie. So imagine this deliciously looking apple pie represents all of recommender systems research. Now, a part of it then is all of the research that is being done on the evaluation of recommender systems. And every year, we contribute a little bit more on our knowledge on the subject as it goes in the scientific community. We come up with a new metric to measure fragmentation. We find out that there's been data leakage if we split our data a certain way. We have a new framework to tune our hyperparameters, and so on and so on. And we make this slice of our pie a little bit bigger. But in focusing so much on apple pie, we're at risk of forgetting that there are other really wonderful pastries out there, like my personal favorite, pecan and caramel brownies. Which I've labeled testing here. So what is testing? Let's talk about testing. But before we do that, let's reflect on how we evaluate recommender systems. And I'm lucky because the previous speaker just explained it so well for us. So what we typically do, both in on and offline evaluation, is we compare the performance of different algorithms by means of some performance metrics. Now, in doing so, we're actually implicitly trusting that our own algorithms and the baselines we compare against are well-designed, correctly implemented, robust, reliable, and free of errors. So are they? Well, I'll talk about that more later, but first let's talk about what I mean when I say testing. So software testing is any activity where we look at some piece of code, we execute it under very specific conditions, and we look at the results and then evaluate if they match our expectations. Now, we can do this manually, or we can do this automatically, as we do in automated testing. And what we say then is that we define what is called a test suite that consists of several test cases, which are really nothing more than a set of specified inputs, execution conditions, and then expected results or criteria that we'll test this piece of software by. Now, all of that is pretty abstract, so let me give you another very concrete example, apple pie. So let's talk about how we would test this apple pie. So our objective is this fully baked, warm, crunchy, but also a little bit moist apple pie. Our test input is the uncooked raw apple pie, and we're going to put it in the oven for 30 minutes at 180 degrees Celsius. I don't know what that is in Fahrenheit, I'm sorry. And then look at it after we do that to evaluate whether or not we've reached our objective. So I hope most of you have at some point in your life baked an apple pie and then know that what we do is we put a fork into the apple pie, and if it comes out clean and warm, that's how we know that our apple pie is exactly right. Now, there's different ways of doing real software testing. I'll quickly walk you through them all, sort of. So unit testing, so we have different levels, first of all. Unit testing is where we look at individual units, like the individual apples that go into an apple pie. In an integration test, we look at components that have already been combined together, like a dough that is made up of flour, butter, other types of things. And in a system level test, we look at the system as a whole, so the apple pie in its entirety. We can do this in different ways. We could do this in a black box test where we cannot look inside. So for example, we'd be looking at the outside of the apple, but we cannot look inside to know whether or not it is rotten or not. Or we can do this in a white box way where we can actually slice into the apple, look at its core, and figure out whether or not it's still fresh. Now, in the same way that apple pie has a ton of properties like sweetness, moistness, crunchiness, recommendation algorithms do too. They can be correct, fair, robust. And in this case, we decided to focus on correctness. So we introduced a toolkit to do this type of testing called RecPack tests, because it's based on our earlier work RecPack. And it contains tests at each of these levels of abstraction, both white and black box. Here's a full overview of them. We currently only support testing collaborative filtering algorithms, but both top K, sequential, and we have specific tests for algorithms that use embeddings or similarities. So, for example, like a lot of the tests in here are really obvious things, like does the model make recommendations for the right users? And by right, we mean users for which we can personalize or we want to be recommending at that moment. But also slightly more complicated things like, is the algorithm maybe prone to suboptimal local optima? Like if we use a different random seed to initialize it, will it get stuck in a solution that is clearly suboptimal to others? So we evaluated this, and I'll show you the results for our own package, RecPack. And even though we already had like 95% test coverage of probably more, we still found a bunch of bugs and unexpected things in our own code. And I highlighted the ones there to show that it's usually the more complicated the algorithm gets, the more likely we are to make some kind of mistake. In these cases, it was, for example, that training was not entirely reproducible because of the way PyTorch does certain things which are just not predictable. You see the same thing, so this is the result for the random seed test, and only 70% of algorithms succeeded it. So in conclusion, I believe that testing could bring a very valuable new perspective to the evaluation of recommender systems, and I really hope more people will consider working on it. So yeah, that's all. Thank you for listening. If you want to try it out, there's a QR code there. You can also read the paper, or you can ask me a question.
Thank you so much, Neem, for the presentation. So time for questions. Again, you can either use the microphone or use the Slido.
Questions?
Any questions? Okay.
Thank you.
Yeah, so thank you so much.